Hello everyone, welcome back. If you have ever wondered how Netflix knows exactly what to recommend you, or how your phone unlocks just by looking at your face, or how Gmail filters out spam automatically, the answer is machine learning. And today, in this one video, I'm going to take you from absolute zero to understanding the full picture of machine learning. No prior experience needed, let's dive in. Here's a quick roadmap of everything we will cover today. We'll start with the basics, what is ML and why does it matter? Then we'll look at the different types, core concepts, algorithms, model evolution, deep learning, the tools you will need, and finally career paths and project. Think of this as a complete ML starter pack. Stick till the end because there's a 6-month learning roadmap waiting for you. Let's kick things off with the very basics. Section 1, Introduction to Machine Learning. So, what exactly is machine learning? Let me explain it with a simple comparison. In traditional programming, you write rules. If the email contains the word lottery, mark it as spam. The programmer writes those rules manually, but in machine learning, you flip this completely. You give the computer thousands of examples, spam emails and non spam emails, and the computer figures out the rules by itself. You don't program the rules anymore. The machine learns them from data. That's why it's called machine learning. A real world analogy, it's like teaching a child to recognize a cat. You don't give them a 50-page manual on what a cat looks like. You just show them hundreds of photos of cats and they learn. Machines work the same way. People use these three terms interchangeably, but they are actually different. Think of it as three nested circles. The biggest circle is artificial intelligence. That's any technique that makes machines behave smartly. Inside that is machine learning, a subset of A where machines learn from data. And inside ML is deep learning, a more advanced form that uses deep neural networks inspired by the human brain. So all deep learning is ML and all ML is A, but not the other way around. When you use ChatGPT or Google Translate, that's deep learning doing the heavy lifting. When a bank detects fraud, that might be traditional ML. When a thermostat adjusts temperature, that could be basic AI rules. Different tools for different problems. Machine learning is not science fiction. It's already running your daily life. Every time Netflix says you might also like this, that's ML. Every time Siri understands your voice, that's ML. When your bank sends you a fraud alert for a suspicious transaction, that's ML. When your phone unlocks with your face, that's ML, specifically computer vision. When Amazon says customer who bought this also bought that, that's ML powered recommendation. And Tesla's self-driving feature, that's deep learning with computer vision processing thousands of camera frames per second. So ML is not just for tech companies, it's in healthcare, farming, education, finance, everywhere. Great. Now that you know what ML is, let's look at the three main ways machines can learn. Section 2, Types of Machine Learning. There are three types of machine learning. First is supervised learning. This is the most common type. You give the model labeled data, meaning you show it input and the correct answer. For example, you show it thousands of emails labeled spam or not spam, and it learns to classify new emails. Think of it like a student learning from a textbook with an answer key. Second is unsupervised learning. Here, you only give the model raw data without any labels. The model has to find patterns on its own. For example, a marketing team gives customer data to an ML model and asks it to group similar customers together, even though no one told it what the group should be. Third is reinforcement learning. This is fascinating. The model learns by trial and error, just like training a dog. You do the right thing, you get a treat. You do the wrong thing, you get nothing. Now let's build your ML vocabulary. Section 3, Core Concepts, Datasets, Features, Labels, and the MA Pipelines. Let's understand the key terms using a real example, predicting whether a bank should approve a loan. The entire table of data we are working with, all the rows and columns, that's called the data set. Each column that we use as input like age, income, and city, those are called features. They are the variables we feed into the model. The column we are trying to predict, in this case, loan approved, yes or no. That's called the label or target. And each individual row, one customer's data, that's called a data point or sample. So when someone says my model has 10 features and 50,000 samples, now you know exactly what that means. Here's one of the most important ideas in ML. You never train your model on all your data. Why? Because you need to test it on data it has never seen before to check if it's actually learned or just memorized. Think of it like exams at schools. You study from your textbook, that's your training data, usually 80% of your data. But the exam questions are new. Those are your testing data, usually 20%. If you have truly understood the concepts, you will do well on the exam. If you only memorized without understanding, you will fail on new questions. There's also a third split called validation data, used while training to fine tune your model, like doing practice tests before the real exam. Here's the step-by-step process every ML project follows. Step 1, collect data, where gather raw data from databases, APIs, or CSV files. Step 2 is to clean data, fix errors, handle missing values, remove duplicates. Step 3, choose a model, decide which algorithm to use. Step 4 is to train the model, feed the training data and let the model learn. Step 5, evaluate. Test the model and measure its accuracy. Step 6 is to deploy. Put the model into production so real user can use it. And here's the most important thing to understand. This is not a one-time process. It's a cycle. You keep improving your model based on real-world feedback. ML is iterative, always evolving. Before we train any model, we need to prepare our data. This is actually where data scientists spend 70 to 80% of their time. Section 4, Data Preprocessing. There's a famous saying in ML, garbage in, garbage out. No matter how smart your algorithm is, if your data is dirty, your model will fail. What kind of problems do we find in raw data? That is missing values. Imagine a form where some people didn't fill in their age. Those cells are empty. Duplicate rows. The same customer got entered twice in the database. Wrong data types. The age column contains text type 25 instead of the number 25. And the outliners. Someone's salary is listed as $9 million, almost certainly a data entry error. Real world data is messy. Cleaning it is not glamorous, but is the most critical step in any ML project. When your data has missing values, you have few options. Option 1, remove the row. If only a small percentage of rows have missing data, just delete them. In Pandas, that's actually df.drop_na. Option 2, fill with mean. If someone's age is missing, replace it with the average age of all the customers. Option 3, fill with mode. For categories data like city, fill with the most common city. Option 4, use a placeholder. Replace with unknown or -1 to signal that data is missing. Which approach is best? It depends on your dataset and the column. There's no one size fits all answer. That's why exploration comes before cleaning. Here's a problem many beginners miss. Look at these three features. Age is 25, income is 75,000, and score is 87. These numbers are on completely different scale. When you feed this into an algorithm like KNN or a neural network, the income feature will dominate everything just because its numbers are larger, not because it's more important. Feature scaling solves this. Minimum to maximum scaling compresses everything to a range between 0 and 1. Now age becomes 0.25, income becomes 0.75, and score becomes 0.87. Every feature plays on a level field. Standardization is another method. It transforms data to have a mean of 0 and standard deviation of 1. Always scale your features before using distance-based algorithm. Skipping this one of the most common beginner's mistake. Now we get into the fun part, the actual algorithms. Section 5, ML algorithms, simply explained. We'll cover 5 essential ones. Linear regression is the simplest ML algorithm and the best place to start. Its job is to predict a number, a continuous value. For example, predicting a house price based on its size. If you plot house size on the x-axis and the price on the y-axis, you get a scatter of dots. Linear regression finds the best fit straight line through those dots. Once you have that line, you can predict the price of any new house just by plugging in its size. The formula is literally y equals mx plus b, the same equation from your high school maths class. Other examples, predicting exam scores from study hours or predicting temperature from month of year. If your output is a number, think linear regression first. Despite the name, logistic regression is used for classification, not regression. Its output is a category, specifically yes or no or 0 or 1. For example, is this email spam or not spam? Is this tumor malignant or benign? Is this transaction fraud or genuine? Here's how it works. It calculates the probability of something being true. If it says there's a 90% chance this email is spam, about our threshold of 50%, we classify it as spam. If the probability is 20% below 50%, it's not spam. So the output is always between 0 and 1, and we use a threshold to make the final decision. Simple, fast, and surprisingly effective for binary classification problems. Decision trees are arguably the most intuitive ML algorithm because they think exactly like humans do. Let's use the loan approval example. The model asks, is the applicant older than 30? If yes, it then asks, do they have a job? If yes, approve the loan. If no, reject it. If they are younger than 30, it asks, is their income above 50,000 and branches accordingly. The model learns these questions automatically from the training data. You don't have to define them. The amazing thing is you can literally draw this tree on paper and explain every decision. That's called model interpretability. The downside? If the tree goes too deep, it starts memorizing the training data instead of learning general patterns. That's called overfitting. We'll cover that soon. KNN is beautifully simple. The idea is if you want to classify a new data point, look at the k nearest points around it and take a vote. For example, say k equals 3. You plot a new customer on a graph. The three closest existing customers are all labeled will buy, so you predict this new customer will also buy. It's literally birds of a feather flocks together. The algorithm doesn't learn anything complex during training, it just stores all the data. During prediction, it measures distances to find the nearest neighbors. The big question is, what value of k should you use? Too small and you're too sensitive to noise. Too large, oversimplify. Typically, you test multiple values and pick the best one. KNN works well with small data sets but gets very slow on large ones since it checks every single data point for every prediction. Now let's see what K means. K means it's a first unsupervised learning algorithm. There are no labels. The goal is to automatically group similar data points together into K clusters. Here's how it works. Step 1, you decide K, say 3 clusters. Step 2, the algorithm randomly places 3 center points on the graph. Step 3, every data point is assigned to its nearest center. Step 4, each center moves to the average position of its group. Step 5. Repeat until nothing changes. Now let's see the real world example. A retail company has 1 lakh customers with no labels. They use K means to automatically discover that customers naturally fall into three groups: budget shoppers, mid range buyers, and premium buyers. Now they can personalize marketing for each group. No human defined these groups, the algorithm found them. You have built a model. Great. But how do you know if it's actually good? Section 6, Model Evaluation. The confusion matrix is the most important tool for evaluating a classification model. Let's say your model predicts whether a patient has cancer. There are four possible outcomes. True positive, the model said has cancer and the patient actually does. Correct. True negative, the model said no cancer and the patient is healthy. Correct. False positive, the model said has cancer but the patient is actually healthy. This is a false alarm. False negative, the model said no cancer, but the patient actually has cancer. This is the most dangerous mistake in medical scenarios. From this matrix, we derive three key metrics. Accuracy is the percentage of all correct predictions. Precision asks of all the people we predicted as positive, how many actually were. Recall asks of all actual positives, how many did we catch. In medical diagnosis, we prioritize recall. We had rather have false alarms than miss real cases. Different problems require different priorities. This next concept is one of the most important in all of ML. Section 7, Overfitting and Underfitting. Now imagine you're studying for an exam. Scenario 1, you barely study, you only learn very basics. On the exam, you score poorly on training and on the test. That's underfitting. Your model is too simple to capture the real patterns. Now let's see scenario 2. You memorize every single past exam questions word for word, including all the weird trick questions. You score 100% on past papers, but the real exam has slightly different questions and you fail. That's overfitting. Your model memorized the training data but can't generalize to new data. Scenario 3. You truly understand the concept, so you score well on past papers and on the real exam. That's just right, good generalization. But in ML, underfitting means both training and test accuracy are low. Overfitting means training accuracy is very high, but the test accuracy is low. The goal is always to find that sweet spot in the middle. Closely related to overfitting and underfitting is one of the most talked about concepts in ML theory. Section 8, the bias variance trade-off. Let's use a dartboard analogy to make this crystal clear. High bias means your model consistently misses the target in the same direction every time, like all your darts landing in the bottom left corner. The model has wrong assumption and is underfitting. High variance means your darts are scattered all over the board. Sometimes you hit the bull's eye, sometimes you miss completely. Your model is too sensitive to the training data and is overfitting. The ideal situation is low bias and low variance. Your darts consistently hit near the center. The challenge is that reducing bias often increases variance and vice versa. That's the trade off. Techniques like regularization, cross validation, and ensemble methods helps you find the sweet spot. Understanding this trade off is what separates good ML practitioners from great ones. Now we are moving into the exciting territory that powers ChatGPT, image recognition, and self-driving cars. Section 9, Introduction to Deep Learning. A neural network is the foundation of deep learning. It's inspired by the human brain. Let's walk through the house price prediction example. On the left, we have the input layer, house size, number of bedrooms, and location. Each of this is a neuron in the input layer. Then we have a hidden layers. These are the layers in the middle that the model uses to find complex patterns. You can't directly interpret what each neuron in these layers is learning. They are finding combination of features automatically. Finally, on the right is the output layer, low price or high price. The deep in deep learning comes from having many hidden layers. A simple neural network might have two layers. GPT-4 has hundreds. The more layers, the more complex patterns the model can learn, but also the more data and computing power it needs. Deep learning is behind almost every breakthrough AI application today. Computer vision, the ability to understand images, power face recognition on your phone, cancer detection in medical scan, and the cameras in self-driving cars. NLP, natural language processing, powers ChatGPT, Google Translate, and sentiment analysis. Speech recognition powers Siri, Alexa, and transcription services like Otter AI. Robotics uses a deep learning for real-time decision making in manufacturing. Game playing, DeepMind's AlphaGo used deep reinforcement learning to beat the world Go champion, something experts thought was impossible. And code generation, tools like GitHub Copilot and Claude use deep learning to write and review code. We are living in the golden age of deep learning. Two of the most exciting and widely used branches of deep learning deserves their own section. Section 10, NLP and Computer Vision. NLP, Natural Language Processing, is about teaching machines to understand and generate human language. When you type a question to ChatGPT and get a perfect answer, that's NLP. When Google Translate converts English to Tamil in real time, NLP. When Gmail knows your email is important or promotional, NLP. Sentiment analysis figures out if a product review is positive or negative, again NLP. Computer vision, on the other hand, is about teaching machine to see and understand images. Face recognition on your iPhone uses CV. Radiologists now use CV models to detect tumors in X-rays, sometimes more accurately than human doctors. Self-driving cars use CV to detect pedestrians, road signs, and other vehicles in real time. Object detection models like EOLO can identify and locate dozens of objects in a single image in milliseconds. These two fields combined are reshaping every industry on the planet. Now let's talk about the actual tools you will use as an ML practitioner. Section 11, your ML toolkit. Here's the essential tech stack for ML beginners. Start with Python. It's the number one language for ML, data science, and AI. It reads like English and has the most powerful libraries. Next, NumPy and Pandas are your first libraries. NumPy handles numerical arrays and max operations. Pandas handles tables of data, loading CSVs, filtering rows, cleaning columns. Scikit-learn is your first ML library. It has ready-made implementation of linear regression, decision trees, KNN, K-means, and everything we have covered today. This is where you will spend most of your early ML time. Matplotlib and Seaborn help you visualize data, creating charts, graphs, and heat maps to understand patterns. Once you move to deep learning, you will use TensorFlow or PyTorch, both powerful framework for building neural networks. And Jupyter Notebook is the interactive environment where most data scientists write and test their code. You can see results cell by cell. Start with Python and Pandas, everything else follows naturally. Understanding algorithms is one thing, deploying a real ML product is another. Section 12, the full ML workflow from data to deployment. Here's what a real ML project looks like end to end. Step 1, problem definition. What business question are we solving? Predict which customer will cancel their subscription in the next 30 days. Step 2, data collection. Gather data from databases, user logs, third party APIs. Step 3, EDA, exploratory data analysis. Visualize and understand your data. Find patterns, outliners, correlations. Step 4 is feature engineering. Create new variables that help the model. For example, days since last purchase might be more useful than the raw purchase date. Step 5, model training. Train multiple algorithms and compare them. Step 6 is evaluation. Use precision, recall, accuracy, and other metrics to pick the best model. Step 7, deployment. Wrap the model in an API so other application can use it. Step 8 is monitoring. Track real world performance and retrain when the model starts degrading. This full cycle can take days to months depending on the complexity of the problem. Building a model in a notebook is the easy part. Keeping it running reliably in production is where ML Ops comes in. Section 13, ML Ops. ML Ops stands for Machine Learning Operation. Think of it as DevOps but for ML models. Once your model is trained, you need to deploy it. That means packaging it as an API using tools like Fast API or Flask, containerizing with Dockers, and hosting it on cloud platform like AWS, Google Cloud, or Azure. But deployment is only the beginning. You also need to monitor, track whether the model is still making good predictions. Real world data changes over time. A fraud detection model trained on 2023 data might start falling in 2026 because fraud patterns evolved. That's called data drift. Finally, retraining. Your scheduled regular retraining jobs to feed new data into a model and keep it sharp. ML ops is a growing field and one of the most in demand skills in the industry right now. Let's bring everything together with three powerful real world examples of ML solving actual problems. Section 14, real world use cases. Use case 1, recommendation systems. Every time Spotify creates your Discover weekly playlist, it's using collaborative filtering, an ML technique that finds users who have similar taste to you and recommends what they liked. Netflix saves over $1 billion a year by keeping users engaged through recommendations. Use case 2, fraud detection. When you make an unusual credit card purchase, say you're normally in Chennai but a charge appears from New York, the fraud detection system flags it instantly. It's running a classification model on every single transaction in real time 24 by 7. Companies like PayPal process millions of transactions per day, and ML is what makes real time fraud prevention possible at that scale. Use case 3, chatbots and virtual assistants. ChatGPT, Alexa, customer service bots, all powered by NLP models. They understand your intent, process it, and generate a natural language response. Modern chatbots can handle 80% of customer queries without a human agents. Now you have the full picture of machine learning. The next question is, how do you actually learn all of this? Section 15, your step-by-step roadmap. Here's a realistic 6-month plan to go from zero to job ready. Month 1 and 2 focus on foundation. Learn Python properly, variables, loops, function, and object oriented basics. Then learn NumPy and Pandas for data manipulation. Add matplotlib for visualization and basic statics, that is mean, median, standard deviation. This is not optional. Strong foundations are everything. Then month 3 focus on core ML. Start with Scikit-learn, implement linear regression, logistic regression, and decision trees on real data sets. Learn how to evaluate models. Month 4, build projects. Apply what you have learned to real Kaggle datasets. Titanic, house prices, iris classification. Write about them on GitHub. Build your portfolio. Month 5, target on advanced topics. Explore neural networks with TensorFlow. Try CNNs for image classification. Dip into NLP basics. Month 6, go real. Build one complete end-to-end project, deploy it on the cloud, publish it on GitHub, and start applying for jobs or internships. Consistency beats intensity. 1 hour a day for 6 months beats 12 hours on weekends. Before you go off and start building, let me save you months of frustration. Section 16, the most common mistake beginners make. Mistake 1, skipping EDA. Beginners often jump straight to modeling without exploring the data. You will miss outliners, imbalanced classes, and key patterns. Always explore first. Mistake 2, data leakage. This is a sneaky one. If your test data somehow influences your training process, for example, you scaled your feature using statistics from the whole data sets including test data, your accuracy will be artificially inflated. Always split first, then transform. Mistake 3, ignoring feature scaling. Many beginners feed raw features into KNN or SVMs and wonder why the model performed poorly. Always scale your features. Mistake 4, wrong metrics. My model is 99% accurate, but if 99% of your data is non fraud and 1% is fraud, and your model just predicts everything as non fraud, it gets 99% accuracy and catches zero fraud. Use precision and recall for imbalanced data. Mistake 5, skipping cross validation. One training test split can be lucky or unlucky. Always use k-fold validation for a reliable estimate. Mistake 6, ignoring overfitting. High training accuracy is not success. Always compare training and test accuracy. Theory without practice is just trivia. Section 17, 5 hands-on projects to build your portfolio right now. Project 1, Titanic Survival Prediction. This is the classic beginner project on Kaggle. You predict which passengers survive the Titanic disaster based on features like age, gender, and class. Use logistic regressions. Project 2, House Price Prediction. Predict house prices using square footage, number of rooms, and location. This is a linear regression project and teaches you the full pre-processing pipeline. Project 3, Iris Flower Classification. Classify flowers into 3 species based on petal and sepal measurements. Great for learning KNN and decision trees. It's clean, small, and beginner friendly. Project 4, Credit Card Fraud Detection. This is an intermediate project with a real imbalanced datasets. You will learn random forest and techniques like oversampling to handle class balance. Excellent for your resume actually. Project 5, Email Spam Classifier. Use naive Bayes or SVM to classify emails as spam or not. You will learn text preprocessing, tokenization, TF-IDF, basics NLP concepts. All 5 of these datasets are free on Kaggle. Start today. And finally, what does all this lead to career-wise? Section 18, the jobs waiting for you in ML. The ML job market is exploding globally and especially in India and Southeast Asia. Let's look at the 4 main roles. ML engineers builds, deploys and maintains ML models in production. Salary range 1,20,000 to 180,000 USD per year globally. Skills Python, TensorFlow, MLOps, APIs. Data scientists focus on finding insights from data and building predictive models. Salary 1 lakh to 160,000 USD. Skills statistics, ML, SQL visualization. Data analyst works with data to answer business questions. This is the best entry level role. Salary 65,000 to 1,10,000 USD. Skills like SQL, Excel, Tableau, and basic Python. NLP and computer vision engineering. Specialized roles in cutting edge AI. Salary 1,30,000 to 190,000 USD. And the best part is almost all of these roles are remote friendly, globally in demand and growing every single year. Machine learning is not just a trend, it's the skill of this decade. And that's a wrap. You have just gone through a complete overview of machine learning in one video. Give yourself a pat on the back. This is just the beginning of your journey, but now you have the full map. Let's do a quick recap of everything you covered. In this single video, you covered ML fundamentals, what it is, types, and how it is work, data preprocessing that is cleaning, scaling, and splitting data, 5 core algorithms that is linear regression, logistic regression, decision trees, KNN and K-means, model evolution, accuracy, precision, recall, and the confusion matrix, the bias variance trade-off and how to avoid overfitting, deep learning, NLP, and computer vision that the cutting edge of AI, your full ML toolkit that is Python, Pandas, Scikit-learn, TensorFlow, and career paths with real salary ranges. That is a massive amount of knowledge. Now it's time to act on it. Here's your action plan starting today. Number 1, practice Python for at least 30 minutes every single day. Consistency is the secret. Number 2, start the Titanic project on Kaggle. It's free, beginner friendly, and will teach you more than any tutorial. Number 3, take a Scikit-learn tutorial. The official documentation is actually very beginner friendly. Number 4, build at least 3 projects and push them to GitHub. That's your portfolio. If this video helped you, please hit the like button. It genuinely helps this channel grow and helps more beginners with this context. Subscribe and turn on notification because we have deep dive tutorials on every single topics from this video coming soon. Drop a comment below. Tell me which topic you want a full tutorial on next. I'll see you in the next one.